All right, so we're going to be talking a little bit about exponent properties. So just thinking back to what we know about exponents, it's some number multiplied by itself a certain number of times. So 5 to the third power, 5 is our base. That's the number we're multiplying, and our small number up here is our exponent. And that's how many times we multiply the base by itself. So 5 to the third is just the same thing as 5 times 5 times 5. And we're going to learn a few little tricks when dealing with exponents that maybe they have a variable as a base. So multiplying powers with the same base. Let's say I have something like x to the 7th power times x to the 4th. Well, if I wanted to do this the long way, I could write out x times itself 7 times. And then multiply it by x by itself 4 times. And if I count them all up, I'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which would give me an answer of x to the power of 11. Now, there's probably a faster way, right? Like if we had some really huge numbers for exponents, maybe we had some 3-digit exponents, this would be kind of annoying to do. And there is a little shortcut. If we have the same base, right? My base is x, all I have to do is add up my exponents. So I'm going to just get x to the 7th plus 4, which is the same as x to the 11th. And we just saved ourselves a bunch of time because now we don't have to write out the whole thing. Now what might that look like if we had some bigger numbers? Because I did mention it makes that easier. Let's say I had do z to the 201 power times z to the 42nd power. Well, we can use our same exact rule we did before. It's going to be z to the 201 plus 42, or just z to the 243rd power. All right, let's try a couple that have some negatives in them. Let's do a to the 5th times a to the -3rd. Well, just like before, I'm going to add up my exponents. So a to the 5th plus -3rd. 5 plus -3. That's just the same as 5 minus 3. So that's going to be a squared. 5 minus 3 is 2. So there's our answer. Let's do one more. Let's do b to the negative 7th times b to the 4th power. Same thing. We're going to add our exponents, and I get b to the negative 7th plus 4. Base is still going to be b. Negative 7 plus 4. Well, our negative is bigger, so our answer is going to be more negative. And we're just going to do 7 minus 4 is 3, but the negative number is bigger, so it's going to be b to the negative 3rd. All right, let's try some division. Again, we're dealing with the same base. Let's say I had x to the 6th divided by x squared. And I want to simplify this. So that way it's just going to be x to some power. So I could do this the long way. And even though we're going to learn the shortcut, knowing how to do it the long way kind of helps us understand why it works, why we can do the shortcut in the first place. So x to the 6th, we're going to multiply x by itself 6 times. That's going to be divided by x times itself, because it's x squared. Now, thinking about what we know about dividing, we know that any number divided by itself is 1. So 5 divided by 5, that's 1. Negative 2 divided by negative 2, that's 1. And a variable is a number. It's just a number that we don't know. It's unknown, but it still counts as a number. So that means x divided by x is just 1. So we can cancel out a few of these x's pretty easily. So I've got an x divided by an x right there. Those are gone. X divided by x right there. Those are gone. So I'm just left with x times itself 1, 2, 3, 4 times, which would give me x to the power of 4. All right, so now we know the long way. And if you think back to when we were multiplying with the same base, you might have already figured out how this is going to go. So when I multiplied with the same base, I added my exponents. When I divide with the same base, I'm just going to subtract. And I'm going to subtract my denominator from my numerator. So it's going to be top minus bottom, which gets us x to the power of 4. A lot shorter, works pretty similarly. Let's try a few trickier ones. Let's go with c to the 100 divided by c to the 25th. One thing we have to do is resist the temptation to divide 100 by 25. A lot of times the problems will make it look like 25 can go into 100, make you think that might be what you need to do. But we got to stick to the rules we know. We have to subtract. So this is going to be c to the 100 minus 25, which gets us c to the 75th power. All right, let's try one. It's a little trickier. Let's do x to the, say, 5th divided by x to the negative 4th. So let's set it up. It's going to be same base of x. I got to subtract my denominator from my numerator. So this is where we have to be careful. It's going to be 5 minus negative 4, which is going to be equal to x to the 9th. Because subtracting a negative, that is the same thing as adding. So this is really 5 plus 4.